Allied forces named it the perfect killer. From tearing apart aircraft 6 miles high to destroying armored vehicles from over a mile out, Germany's 80mm Flak cannon became the most dreaded weapon across every World War II front. Created through secret agreements that broke the Treaty of Versailles and designed for both air and ground combat, its speed and deadly precision created a new level of devastation. A single round could explode into 1,500 sharp metal pieces, filling the sky with lethal dark bursts. But how did an anti-aircraft weapon transform into the war's greatest multi-purpose gun, changing battle tactics from Spain to Stalingrad? The story reveals hidden origins, constant improvements, and a competition nobody wanted to lose. Krupp's designers, hiding from the Versailles Treaty rules, used Sweden as their secret partner. What they built wasn't just a way around Allied limits, it created new standards for artillery engineering. The Flak 18, featuring its 4.9-meter L-56 barrel, was first to appear. It mounted on a cross-shaped base that could spin completely around, letting operators follow targets in every direction, shooting up to 20 shells per minute. The weapon used an automatic horizontal sliding chamber. Each blast threw out the empty case and prepared the firing mechanism for the next shot. This saved valuable seconds during each firing cycle. Movement was designed from the beginning. The gun traveled on double-wheel supports, one at each end. When operators reached their shooting spot, they would lift the carriage, drop the stabilizers, and have the platform steady and ready to fire in about 2.5 minutes. The system worked smoothly. Shell handlers passed rounds to the loader, who matched timing with the chamber. The gun leader shouted target information sent from the battery's control unit. On the left side, the fuse timing machine let 2 shells be prepared together for exact air explosions. Even under attack, crews could keep the weapon loaded and shooting at a constant rate. The Flak 18's design was strong but could be improved. When heavy firing wore out barrels, repair teams had problems. The original single-piece barrel meant the entire tube needed replacement. This improved with the Flak 36. This model brought a 2-piece barrel design. Field teams could now change just the damaged part near the chamber, reducing time and keeping weapons working longer. The Flak 37 came next, adding better instruments that helped crews react quicker to commands from central control units. Parts between these versions were almost completely swappable, a smart decision to make supply and fixes easier in battle. With each improvement, the 80mm's main advantages, quick setup, fast firing rate, and reliable mechanics, became the foundation for its future uses. The weapon's cross-shaped mount and rapid turning, its auto-eject chamber, and its replaceable barrel all showed a system ready for more than just hitting bombers above. These design decisions prepared the 88 for its next change, serving as the center of radar-controlled batteries and soon as a weapon just as lethal against tanks as against planes. The 88's first real anti-aircraft test happened not above German territory, but in the dirt and confusion of Spain's civil war. German operators with the Condor Legion organized in 4-gun groups, each weapon positioned for overlapping coverage and fast communication. Every group depended on a 5-person fire control squad gathered around a Commando Garrett director, a mechanical computer with a 4-meter stereoscopic rangefinder. Their task was tracking height, speed, and direction, sending this information to gun crews through cables and display dials. When enemy planes got closer, the director figured out the exact timing and altitude for each shell to explode. 2 workers at each gun loaded rounds into the Zündestell machine, a mechanical fuse device mounted on the weapon's left side. With each turn, the machine set the timing fuse for 2 shells together, matching the director's calculations to the exact second. When the command came, loaders pushed the shells in, and the 88s responded with a beat that never stopped. At maximum speed, a battery could send 80 rounds into the air in 60 seconds. Each explosive shell weighed slightly more than 17 pounds. When it exploded, it threw over 2,500 jagged pieces outward in a dark cloud, the trademark of German Flak. Pilots nicknamed them Black Puffs, but for airmen inside the bombers, the damage was instant. Windows breaking, engines failing, control parts ripped apart by invisible metal fragments. Fuse timing was critical. Too quick, and the shell exploded harmlessly underneath. Too slow, and the pieces spread in empty space. The Commando Garrett's math combined with the exact work of the fuse operators made the difference between a miss and a direct strike. By the early 1940s, German batteries had introduced Würzburg radar into the system. Now the director team could follow targets at night or through clouds, sending distance and direction information directly to the guns. Each new advance, better directors, clearer optics, and quicker fuse machines, meant that flak batteries could coordinate fire with an accuracy that Allied airmen came to dread. The process was precise: director to display, display to fuse operator to loader, loader to chamber. Every connection counted. Even as the 88's fame grew for ground attacks, its main power stayed with this battery teamwork: mechanical, human, and mathematical, built to fill the sky with deadly explosions exactly where enemy aircraft would fly. French armored vehicles pushed through Monast in May 1940, their heavy protection deflecting the regular German anti-tank weapons. But on the hill, operators from the 38th Flak Regiment turned their 88s toward the battlefield. These guns, built for high-altitude bombers, now aimed at ground enemies directly. At distances beyond 2 kilometers, the first armor-breaking rounds smashed through the hull of an 18-ton tank. 2 Char B-1B heavy tanks came next. One struck in the motor, another in the turret. Both exploded from inside, ammunition igniting, crews killed immediately. Even undamaged tanks were left behind as panic spread. Outside Paris, 4 days afterward, British Matilda IIs moved forward, their 78mm front armor making them almost immune to the standard Pak-36. The 88s broke through the chaos, firing from hidden positions. Matildas, believed unstoppable, fell apart at ranges where their own weapons could barely hit back. German crews moved quickly, dropping the supports, lowering stabilizers, and aiming the guns in less than 3 minutes. With each shot, the chamber automatically threw out the shell, prepared the firing pin, and the loader pushed in another round. Within minutes, 24 British tanks were left burning or disabled. Army records documented the result. The 88 had stopped the advance completely. Towed Flak 18s and 36s weren't the only solution. As the conflict continued, the weapon's fame spread. By 1942, the Tiger I came from the factory with the KWK-36, a tank gun version of the 88, placed in its turret. The vertical sliding chamber, the same physics, the same harsh accuracy. Crews carried 92 rounds, often packing more into every available space. The Tiger's gunner could strike a moving target at 1,500 meters with one shot, sometimes even farther. Tank hunters like the Nashorn and Ferdinand carried the Pak-43, a longer-barreled, higher-speed 88 with a muzzle speed of 1,000 meters per second. At 2,000 meters, the Pak-43 could break through the thickest Allied armor. Ammunition lists from 1944 showed explosive, armor-piercing, hollow charge, and solid-shot rounds. Each type had a purpose: demolish bunkers, destroy tanks, or blast through reinforced targets. Delayed fuses allowed shells to pierce armor before exploding, turning a glancing blow into a deadly strike. Gunners mastered switching between types in seconds. The 88's fame grew. Tank crews feared the distinctive crack, foot soldiers stayed low, and Allied commanders changed their plans to avoid its range. On every battlefront, the weapon's ground combat power was felt. Whether buried on a hilltop, mounted on a Tiger, or hunting through destroyed towns on a Nashorn platform, British and American planners examined the 88's dual-role reputation, comparing it against their own heavy anti-aircraft weapons. On paper, the British 3.7-inch at 94mm could launch a shell higher and farther. The U.S. 90mm with its power loader could equal the 88's firing rate, sometimes reaching 20 rounds per minute. But both Allied weapons weighed nearly 2 tons more than the German gun, and their mounts weren't made for quick changes between rolls. Moving a 3.7-inch needed a heavy truck and a complete crew just to set up, making sudden anti-tank operations almost impossible. The American 90mm was fixed for air defense, its crews trained to focus on the sky, not the battlefield. German strategy demanded different flexibility. In combat, 88mm batteries could lower supports, set up, and fire in under 3 minutes. Crews practiced switching from anti-aircraft to anti-tank shooting instantly. That mobility, combined with a gun that could turn 360 degrees and maintain a steady 15 to 20 rounds per minute, made the difference on changing battlefields. Allied gunners took notice. The 88 wasn't just a technical victory. It was a system designed for shifting dangers, and its crews trained to use that advantage. The legend built on both sides of the war. British tank crews learned to fear the first crack of an 88 from beyond a mile. American soldiers called it the anti-everything weapon. Its reputation spread faster than its shells. Even as Allied guns matched or beat the 88's numbers in testing, few could match its battlefield impact. The weapon's fame became its own kind of tool, changing tactics and morale long after the first shot was fired. In the end, it wasn't just the metal and the mathematics. It was how the 88 was employed and the stories it created that made it the war's most legendary big gun. By 1944, German documents showed more than 21,000 88mm weapons built, serving in anti-aircraft, anti-tank, and vehicle-mounted roles across every European battlefield. From a secret project avoiding Versailles limits to a coordinated air defense network to the backbone of German armored and anti-tank forces. Its reputation was earned through proven adaptability, quick rotation, high firing rate, and the power to defeat both bombers and heavy tanks. Allied reports consistently identified the 88 as the most feared German weapon. Yet much stays hidden about its complete operational losses and the secret